Okay, I am super excited about this unit because this new unit that we're going to be doing is called the mole, okay? And this is everything, let me say that again, this is everything that we do in chemistry. Everything we talk about in chemistry revolves around this thing called the mole, okay? No, not a tiny little furry animal. No, this isn't some person who has infiltrated your clique, who's pretending to be your friend. This is a chemical quantity, so something we use in chemistry to measure the stuff that we're talking about, okay? So I want you to take a second here and think about this. First of all, these notes are on page 149, okay, or start on 149. So every year, there's this contest where these big elaborate sand sculptures are built, okay? Each contestant creates these creations out of millions and millions grains of salt or sand. Could you measure the amount of sand in each one of those sculptures? Okay? And so I want you to take a second and see if you can think of an easy way to do that. Okay? So go ahead and take a second to do that. Pause the video and think about that. Okay? Hopefully, you came across something or developed some sort of idea of saying, okay, if I know a certain amount of volume and I can count each particle of sand in that volume and then weigh it, right? You could ultimately figure out how many grains of sand are in each sand castle by counting, by knowing the volume, and by weighing, okay? So, and that's how we often measure things, by counting, by weighing, by using its mass, and by how much space that substance takes up. Okay? So let's talk about the mole. Okay. A mole represents this big number, 6.02 times 10 to the 23rd particles of something, okay? And we call this Avogadro's number. You are responsible for this value, okay? So in chemistry, we are dealing with things that are really tiny that we can't see, okay? So with that being said, when we talk about different substances, we need to talk about that each one of those substances has 6.02 times 10 to the 23 particles. So when I'm talking about one atom, I'm talking about it having 6.02, or 1 mole of an atom. I'm talking about it having 6.02 times 10 to the 23 atoms within that 1 mole. Okay, let's kind of think about this for a second. If I say to you 1 pair, do you know what I'm talking about? Or how many I'm talking about? Hopefully you say 2. Okay, what if I say a dozen? Do you know how many I'm talking about? Yes, I'm talking about 12. What about score? I know that you've heard this before. 4 years ago, right? That's the Gettysburg Address by Abraham Lincoln. 1 score is actually 20. Okay? So when I say 1 mole of something, I'm just saying it's a quantity, like a pair is 2, a dozen is 12. 1 mole of something is 6.02 times 10 to the 23. And it can be about whatever we're talking about. It can be about molecules, it can be about atoms, it can be about particles, it can be about energy, which we call photons. It can be any one of those things. I want you to know or associate the word mole with 6.02 times 10 to the 23 something, okay? So let's look at a couple of examples here. So if I'm looking at this table down at the bottom, okay, if I have carbon, carbon is an atom, the chemical formula is just C. How many particles are inside of 1 mole of carbon? And that's going to be 6.02 times 10 to the 23. And since this particle is an atom, I'm going to write atoms. Now, to figure out how many grams are in 1 mole, this is what we use the periodic table for. Okay, so if I look at the periodic table, the mass for carbon is 12.01 grams per 1 mole. And we'll talk more about this when we get to molar mass. Okay? Let's do nitrogen gas. Nitrogen gas is a molecule because nitrogen is a Hofbrinkel, which means it's N2. Okay? Which means for every 1 mole of nitrogen, I will have 6.02 times 10 to the 23 molecules of N2. And if I look at the periodic table, 1 nitrogen is 14, so 2 nitrogens is 28 grams. Okay? A copper ion. Well, obviously it's an ion. We're going to say that this is copper plus 2. Okay? Which all that means is that I have 6.02 times 10 to the 23 ions. And copper weighs, let me see here, 63.55 grams. Okay, I'm going to do one more. Calcium fluoride. Calcium has a +2 charge. Fluorine has a -1 charge. So calcium fluoride is CaF2, which makes this a molecule. Okay, I switched these two, I'm sorry. Which means I have 6.02 times 10 to the 23 molecules of calcium fluoride, and then you can look up its mass. Okay, so what can I do with this kind of information? Well, I can learn how to convert. Okay, so if I have a certain amount, I'm going to skip number 1. If I have a certain amount of atoms of nitrogen, I can use my conversion of 6.02 times 10 to the 23 something is equal to 1 mole of something. So just like I taught you how to factor label, we can convert from moles of something to the particle of that something. Okay, so let's look at number 2 here. The question states, how many moles? So I say, what's my question mark? Question mark moles are in 1.25 times 10 to the 23 atoms of nitrogen. Okay, so this is moles of N2 is what I'm looking for. Okay, is equal to my given, which is 1.25 times 10 to the 23 atoms of N2. No number should not have. I'm going to set up my conversion. Okay, what unit am I canceling? I'm canceling atoms. So atoms of N2 goes in the bottom. I want moles of N2, so that goes in the top. And then I ask myself, what number lines up with the unit? So 1 lines up with mole, and 6.02 times 10 to the 23 lines up with atoms. Okay, now something really important when you plug this into your calculator that you need to realize is that I'm not going to do times 10 to the 23. I'm going to use my EE button to plug this in. So what I'm going to do is I'm going to say 1.25, and then I'm going to go on my calculator. It's second EE, which gives me an E, to the 23rd times 1 divided by 6.02 E 23rd, and I get 0.208, which I started with 3 sig figs, so my answer should also have 3 sig figs, which it does, moles of N2, okay? Which that makes sense, right? Because I have 1.25, which is less than 6.02, which means that my mole value should be less than 1, okay? Let's do another one. Number 3 says, how many moles, okay, so my question mark is moles again, are in 2.80 times 10 to the 21st molecules of water. So I'm looking for moles of H2O, and that is equal to 10.80 times 10 to the 21st molecules of H2O. Okay, so I'm canceling molecules, so that'll go on the bottom. I want moles of molecules, so that'll go in the top. Or, I'm sorry, moles of H2O, so that'll go on the top. So for every 1 mole I will have 6.02 times 10 to the 23rd. So I'm going to plug that into my calculator. So 2.8 E21 times 1, which is just itself, divided by 6.02 E23. And I get 0.00, I need 3 sig figs, 465 moles of H2O. Okay? Sorry. 0.00465 moles of H2O. Go ahead and try number 4. That's the one that I'm going to check in class. Okay, now what if I want to go the other way? Okay? What if I am given moles and I'm trying to figure out how many molecules or atoms or ions are present? Okay, so let's look at some examples here. A says, how many atoms, okay, so question mark atoms of Cu, which is copper, is equal to 3 moles of copper. Okay, so I'm going to say, this time, moles is in the bottom, so moles of copper goes in the bottom, and I want atoms of copper, so that goes in the top. And for every 1 mole, I have 6.02 times 10 to the 23, which I'm just tripling the amount of atoms I have, and that I should get, which I only have 1 sig fig, so it'll be 2 times 10 to the 24 atoms of Cu. Okay? I'm going to do one more really fast because I'm running out of time here. What if I look at this one? It says, how many molecules are in 5.3 moles of nitrogen gas? Okay, so I'm going to say question mark, molecules, N2 gas is equal to 5.3 moles of N2 gas. So same thing. Moles of N2 goes in the bottom. Molecules of N2 goes in the top. Okay, because moles is going to cancel. So for every 1 mole, I'll have 6.02 times 10 to the 23rd. So I'm going to do 5.3 times 6.02 times 10 to the 23rd. And with 2 sig figs, I should get 3.2 times 10 to the 24th molecules N2. Okay? Go ahead and try this one. I will also check that one to give you homework credit. And we'll go over some of these problems in class tomorrow. Thanks, guys.